Hi, welcome to the Unit 6, Day 5 PreLab help video. So in this lab, you are going to be using the percent composition of your hydrate to identify which one of these hydrates it can be. Now, as we know, hydrates are ionic compounds, at least the hydrates we're dealing with. They're ionic compounds, so metal and non-metal, that have waters loosely attached to them. And you could remove these waters by heating them. Now, because these waters are in a particular ratio, like for example in this hydrate, it's one ionic compound to one water, and we know that because the number in front of the H2O is an invisible one, so it's a 1-to-1 ratio. Because they have a specific ratio, they have a specific percent composition of both the water and the anhydrous salt. So what you're going to do in your lab today is you're going to gather some data. And then you're going to use that data to get to determine, this will be in your calculation section, the percent composition of an anhydrous salt, okay? And whatever number you get here, you're going to compare it to the values in the last column of this PreLab table and use that to identify your unknown. So let's say, for example, from your data, you get the percent composition of the anhydrous salt to be about 89%. Well, that would match this value here. So then you would scroll over and you go, boop, oh, it's got to be this one. So this is my unknown salt, right? If, on the other hand, your value came out to be about 63%, you would look, oh, this is about 63%. Then you would scroll over and find that it's this salt here, the one with 5 waters in front of it. Okay, so in order to be able to use this table, we actually have to complete it, because as you notice, I did most of them, but there are a few blanks here because I want to give you guys a chance to practice and show me that you know how to do this. So what you're filling out here is the percent composition of water in each of these hydrates, so you're doing these two here, and the percent composition of the salt, the anhydrous salt in each of these hydrates. So before we get into the math, I want to just sort of do a quick review about percents for you. So when we say percent, remember percent is always the same thing. It's always your a part over your whole times 100. That's how we get the percent of anything. Now in the case of these hydrates, the whole thing will be the entire molecule, right? And just so you guys know, just so it's clear, this N is the number of waters. So there would actually be a number here, but we're using an N because this number could be 1, 4, 5, 6, or 7 as shown in the table. But anyway, so your whole would be the entire molecule. And the two parts that there's the anhydrous salt and then there's the water, okay? So if you wanted to calculate the percent composition of the water, the part would be the water, and you would get the mass of water. And the whole would be the entire molecule. You would get the mass of the entire molecule. So you take the mass of the water, which is your part, divided by the mass of the entire molecule, which is your whole, and then multiply it by 100%. Now, well, where do we get the mass for the water and the mass for the entire thing? So let's start off with the mass for the entire thing, the whole. This is just the molar mass of your hydrate. So you would just get this information, you would use the periodic table, you would add up the number of the masses for iron, sulfur, oxygen, and the hydrogens in this molecule to get the molar mass. Now, of course, you could calculate it, but fortunately for you, I have calculated all of the molar masses, and they're written under here. So this would be the value that you would be using as your whole. But what about for the part? For the top part, the mass of the water, you actually have to calculate that. And the way that you calculate it, it's going to be the number of waters, so the N, right, times the molar mass of water, which is 18.02 grams per mole. So this is where we get that number from. So whatever the number is in front of water, so it's 1, 5, 4, 6, 7, you multiply that number by the molar mass of water, which is 18.02 grams. So then you would divide these two numbers and multiply by 100. Okay, so that's how we filled out this first column here. We're going to skip this first one. This one is for the anhydrate. So notice that there's no waters here. So the mass of water would be 0, but the overall the molar mass of the whole thing would be this value, 151.92. Let's take a look at the second example. I'm actually going to zoom this in. Oops. So it's a little easier to see. Okay, so how do we get this percent composition of water? Well, what we did was the number of waters in this molecule is 1. There's an invisible 1 there, right? So we do 1 times 18.02, which is the molar mass of water, and then divided by the molar mass of the entire thing, which would be the molar mass of this hydrate, and let's plug that in, right? Okay. And then we multiply that by 100, and this is how we get the 10.6. This is the one that you're going to do, so let's take a look at the next example underneath it that we've done. So how do we get this value? We did the molar mass of water times 5, so this number here, right, of water. That's how we got that number. 5 times molar mass of water, we get a number on top. And then on the bottom here, we have the molar mass. We just plugged in the molar mass. Okay. So in terms of what that looks like in your calculator, and I'll actually calculate this one for us so that you can see what we're doing in the calculator. So that part's clear. Okay. Slide off for a second here. All right, so the first thing we need to do in our calculations, we would do the 5 times the 18.02 and hit enter, and you get some number, okay? I got 90.1. And then I would divide that number, so divide that answer by the molar mass, so that 242.0, oops, 0.02, okay? Then I get this number. That's a decimal number. I need it in percent, so then I would just multiply by 100. And I'm using up to 2 decimal places, okay? And so that's how I got that number here, 37.23, because I cut it off at 2 decimal places, okay? So that's how you would do this part. Now, if you get stuck, you have these as a guide, so just follow along. I also have linked an online resource, so you can see that as well. Now let's talk about the last part. So we've gotten the percent composition of the water. Now how do we get the percent composition of the anhydrous? Well, another thing we know about percents is that when you take the overall percent of anything, it's always going to add up to 100. And since this substance only has 2 parts, it only has the anhydrous part and the water part, if we know the percent of water, then the percent of the anhydrous is going to equal to 100 minus the percent of water, right? So let's say, for example, the percent of water was 30%. Well, that means that the percent of the anhydrous must be 70, because 70 plus 30 would give me overall 100, okay? So that's what we did over here. Essentially, what you do to fill this out is if you look at this example here, we got the percent of water to be 10.60%. Well, we would do 100 minus that 10.60, and that gives me the percent of the anhydrous, okay? And that's how you fill out this table. Now, this is the value that you're going to use when you are trying to figure out, you're going to use the values in this table to figure out what your unknown is, okay? So it's important that you can calculate both of these things. All right, that's it for this pre-lab video. If you have any questions, message me in Schoology. Have a quality day.